In this video, we will learn about chemical properties of ammonia. The first one we have stability. Ammonia gas is fairly stable but dissociates on heating or passing electric spark. So ammonia is basically stable but it will be decomposed or dissociates on heating at around 500 degrees Celsius into nitrogen gas and hydrogen gas. As we know that the reaction is also reversible. Now basic character, we know that ammonia dissolves in water and releases hydroxide ions. The solution is weakly alkaline or basic. So NH3 on reacting with H2O will produce ammonium hydroxide, which can be dissociates into ammonium ion as well as hydroxide ion. Action of indicators, we have it turns red litmus blue because of its alkaline nature. Then it gives pink color with phenolphthalein. Then it gives yellow color with methyl orange. Then the second we have formation of salts. As we know that ammonia is basic in nature, it forms salt with acids. Ammonia on reacting with HCl will give us ammonium chloride having white dense fumes. Then ammonia also reacts with sulfuric acid to form ammonium sulfate. It also reacts with nitric acid to form ammonium nitrate. Some salts are produced when ammonia is first dissolved in water to get ammonium hydroxide. So again, ammonium hydroxide on reacting with HCl will give us ammonium chloride along with the water. So simply an acid and base reaction, which is acid on reacting with base will give us salt and water. Now here we also have the same reaction, which is ammonium hydroxide on reacting with sulfuric acid will give us a salt, which is ammonium sulfate along with the water. Then ammonium hydroxide reacts with nitric acid to produce a salt, which is ammonium nitrate along with the water. Then the fourth we have reaction with carbon dioxide. When ammonia reacts with carbon dioxide, it forms urea, which is a valuable fertilizer. Ammonia on reacting with carbon dioxide at 150 degrees Celsius and 200 atm pressure will give us urea, whose formula is NH2CO NH2 along with the water. Then the preparation of hydroxides of heavy metals. Ammonium hydroxide react with soluble salts of heavy metals to give precipitates of their respective hydroxide. These precipitate form differ in their color and solubility. Hence, ammonium hydroxide is used in qualitative analysis of cations. So here we have the metal salt solution, which is of iron chloride, then aluminum chloride, chromium chloride, zinc nitrate, lead nitrate, and copper sulfate. They all react with ammonium hydroxide, and the reactions will give us the ammonium salt, which is ammonium chloride, ammonium nitrate, and ammonium sulfate. The metal hydroxide precipitate is going to be, we have ferric hydroxide, aluminum hydroxide, chromium hydroxide, zinc hydroxide, lead hydroxide, and copper hydroxide, whose color of the PPTs are different. The first one we have reddish brown, which is insoluble in excess of ammonia, then white gelatinous in case of aluminum hydroxide, which is again insoluble in excess of ammonia. Then dirty bluish green in case of chromium hydroxide, which is again insoluble in excess of ammonia. But in case of zinc hydroxide, we have a white color PPT, which is soluble in excess of ammonia. Then in case of lead nitrate, we again will get white PPT along with the insolubility in excess of ammonium hydroxide. Then the light blue, which is soluble in excess of hydroxide in case of copper sulfate. Then the next we have complex formation tendency. It forms complex compounds with copper 2 ion, which is Cu2 positive, and zinc 2 positive, as well as silver ion. For example, when ammonium hydroxide solution is added to blue colored copper sulfate solution, a light blue precipitate of copper hydroxide is first formed. So here is the reaction, which is copper sulfate on reacting with ammonium hydroxide will give us simply light blue PPT. We just saw this on the last table along with the ammonium sulfate. Now, if we pass excess of ammonium hydroxide in this, the light blue precipitate of copper hydroxide dissolves to give us more deep blue color soluble complex, which is called as tetraamine copper 2 sulfate, whose reaction is this only. Now we are passing excess of ammonium hydroxide, which will give us this complex, which is deep blue, and its name is tetraamine copper 2 sulfate along with the 4 molecules of water. Then we have zinc hydroxide, which again precipitate dissolved in excess of ammonium hydroxide to form tetraamine zinc 2 sulfate, and here is the reaction we have. So which will form a complex, which is again a soluble complex, tetraamine zinc 2 sulfate. Same thing happens with silver. Silver chloride goes into the solution with excess of ammonium hydroxide forming a soluble complex. So AgCl on reacting with ammonium hydroxide will give us diamine silver 1 chloride, and water is evolved as a byproduct. I hope it is clear to you. Thank you.